Okay, hello everyone. So today we want to learn about Dijkstra algorithm. So many people ask about me is like how to code the code Dijkstra algorithm. So I'm replaying this video to them. So let's go to tutorial first. So what is the Dijkstra's algorithm? So it solves the single shortest path problem on weighted and directed or undirected graph. Both can be used, but it solves that weighted edge. So let's take an example. So how the graph would look. So those who don't know about that graph tutorials at all, they can go to previous videos where I explained about the graph. So here there is an example where we have that five vertices S, T, X, Y, Z, and you can see that edges are defined there. It's a directed graph. So we have the edges from S to T, and its weight is 10. So problem is that we have to find the shortest path from source, single source, to all the vertices. So suppose so what it will return? It will return a list containing the all path from S to all vertices. So suppose it will contain that S to T, what is the shortest 10 suppose, and from S to Y, S to Z, and S to X. So initially what we will do, we will use a array of size v is the number of vertices, and initialize it to false. It's like all are not visited, and source will be provided given as we will be solving this problem. So I just take an example from Geeks where it is given the source, and we will code it in Python so that it can cover in minimum time. So here also you can take one of the example where the S is given to the source will be single, but it can be anything, and we have to put that from 2 to suppose 0, what is the minimum distance? 3 plus 1 4. 2 to 1, what is the minimum distance? 3. And 2 to 0, what will be the minimum distance? 2 to 2, it will be itself 0. So let's go to this graph, which is looks like more complicated and will be easy to solve. So we will be using the visited array source, and we will be using a distance that can contains what is the distance from source to all vertices. So initially I just initialize with the all are infinite. INF is like infinite, any maximum values we can use. And graph can be represented in, as we all know, graph can be represented in two ways. It's either adjacency matrix or adjacency list. So it depends, we can use any way, but algorithm will be the same. So let's initialize with this. So suppose our graph is 0, source is 0. So what we will do, first, distance of source is equal to 0. So what it will do, now distance will array will looks like this. Okay, and yes, so now what we will do, from S we will take all those edges which are going outwards and select the minimum one. So from S we can see we have two edges, one going to T, one going to Y. So we will update our distance matrix accordingly. So what will be the distance now? So from S to S is already 0. From S to T, previously it was infinite. Now we found the one edge from S to T which having value 10. 10 is less than infinite, so we will update to 10. Now we will go to previously S. Let's name the vertices S, T, X, Y, Z. So from S to S is 0, S to 2 10, S to X. X will again, there is a no direct path, so it will be as it is infinite. X to Y we have the one edge which is 5. 5 is less than infinity, so we will update it the 5. And X, Y, Z. Z itself there is a no direct edge, so it will be infinite. After this, what we will do, we will update our vertex visited array. So now source is visited. So what we will do, it's true, false, 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 false. All other are false. Now, what is the minimum age here? You can see here the minimum value is at 0, 1, 2, 3, third index. What is this? Which is y. So we will choose now y. So here now we will choose the y. From y we will check all those yes. So here previous value is this. We only have to update only these values, and at the end we will get the result. So this is the previous value. Let's copy this also. Yeah. So now we are taking as a y as source. So from y we can see there is a 1, 2, 3 edges directly going, right? So from y to t. So previously uh, at y, what is the value? Y we have the initial value is 5. So initial is equal to or you can say y is equal to 5. So from y to t there is a path which has the edge weight value is 3. So if we go, we have t is 10 and 5 plus 3 is less than 10. So we will check 5 plus 3 is less than 10. Then what we will do, we will update this edge. So now distance will be 0, 8, now we have x. So now we have a x directly which is having value 9. 9 plus 5, 40. We will be using 40, and then s t x y, y is itself already is given 5, and then z. From z we have this path 2. 2 plus 5, 7. So we are at y, so initial value will be like our y is 5. So we whatever edge we will have, we will add y's value to this, because we have to find the path from source. So source to y, it costing us a 5 because it was the minimum. So from y, whenever we will go, we will add this value at least, because we have to find the path from source. Yes. So now distance will be from source, because this is we are counting from the source. From source to s is 0, t is 8, y x is 14, which is 5 plus 9, and y is 5 itself, 7 is, and its y is already visited, so we will mark y as also visited. So s is 2, t we haven't discovered x, but we discovered y, and we have discovered z. Okay, so we have discovered 2 edges so far. Now coming to next. So what is the minimum? Yeah, so after minimum you can see here 5 is already discovered, 0 is already discovered. So after that we have minimum is 7, which is the last z edge. So now we will explore from z. So distance was previously, what was the distance? If we go, this was this. Okay, and z is, if we take z, what is the value of z is 7. So from 7 there is only one path which is going to x. X is 30, but here we already see is x value is 14. So if we go from by this, the value will be 30. So we will update this to 30, because 7 plus 6 is less than whatever the value currently we have it distance. So we will update this. Now we will mark visited of z is also true. So it was already true. Let's see what was there in here, because we have only one edge from z. So it is also true. Now what is left? So the last two is true, already visited. Now we have 2. So 8 and 30, out of 8 and 30, which is minimum? 8 is minimum. So we will take that tth. So let's go to tth. Time that already passed. So let's initialize the distance. So from t there is only one edge which is going to x and value is 1. So you can see the currently from s to x distance is 14. But if we consider this path, so this will be like t plus 1, which is 9, which is less than 14. So we will update to this also. So now distance will become 9, because what is the t value? T value is 8, and 8 plus 1 less than 40. So we will update this value to 9, and we will make visited of t is also true, because there is no other edges remaining here. So s is true, t is also true. Now we have only x, which is false. So go to the last chapter of our this. So currently our distance is this 08957. Now if we go from x, there is only one edge which is 4. So if we go to this way, so 9 plus 4 is less than whatever the value we have 7 is false, so we will not update. So this will be the final result, and we will mark instead of x is also true. So instead will be like so once all visited, we will return distance. So this will be our output. So you can say that from s to s0, s to t will be the 5 plus 3, shortest path 8. S to x, x will be 5 plus 3 plus 1, 9. S to y is 5 only, and s to z 5 plus 2. So this will be our shortest path from source s. So now coming back to this algorithm. So how to solve this? So here we have a graph. V is vertices. Let's see first how it will be represented here in adjacency. Is it list or compile? List or matrix? So I'm just running this simple test case just to print adjacency representation. Okay, it will record something like return list. Okay, let's return empty list, because after that it will doing the processing. So you can see here it's representing the array of basically list of list, where list represent first represent that which is connected, and second point represent that weight of this. So from 0 to 9, 1 to 9. Okay, so here you can see that we have two vertex, one edge, 0 to 1, 9. So for 0 to 1 is like, for 0 to 1 we have 1 9, and for 1 we have 0 9. It's an undirected graph, so both we have to represent. So let's go to the approach we have to solve. First we will make a distance matrix. So let's use the small one. So I'm using, like, here you can see that maximum value of, so what is the maximum value here we can find. That is maximum value 1000, maximum weight it can have. So we are taking is like 100,000. Just put it aside into size of vertex. Now we have visited is equal to false into v. So we have that v is the number of vertices. So we have distance and visited, which is initialized to maximum values and false initially. Now what we will have? We will have distance of s, which is source, is equal to 0. Now we will call, suppose, get minimum distance. We are writing another function. It will return a list. So what we will pass? We will pass here that matrix, visited array, and distance. Okay, so let's define this. So what we will do, we will traverse till all visited are not there. So we will write another function that will calculate the minimum. So every time what we will do, we find the minimum of this distance, right? So suppose we have the one function that will give the minimum with index, or here we can say self dot get minimum from list. Here we will pass distance and visited. Okay, so what it will return? It will return minimum value from distance matrix with its index. So let's write this function also. We have to include some function. Okay, so let's initialize the maximum value which we use here, 100,000, because we have to find minimum. So we will initialize one maximum value and compare all the elements with that, and we will make size of, let's say, distance matrix. Okay, so for I in range, let's initialize index also, which is -1. I in range of, you can say n, if the vertex is not visited. So we can have visited of I, and distance of I less than m, m is equal to distance of I. So it will give the index, or it will the index is equal to I. Return m comma index. So this function what will do, it we have provided that distance array and visited one. So it will give us traverse whole array and find the minimum value with its index. It's a common function we use to provide in beta first year. So we got this minimum index. Now what we will do, first we will check if index is equal to -1. What? So if it is -1, then it's like there is no minimum found, and index will return -1. So it's like all our vertices are visited, so we will break, right? Else we will first mark visited of index is equal to true, right? And now for whatever the index we get, we will check in all those edges of that index, right? So for n is like node in list, agency list of that index, and check if that index not visited, right? And so here we already see n will return two values, 0 and index. 0th will be like index and 1 will be like edge. So we will pass if this is not visited, and if distance of n of 0 is greater than distance of current index, whatever the index we have, plus n of 1, then distance of n of 0 is equal to whatever the value is this similar is initializes this. Okay, and then it will return distance. Here we return this and return distance used here. So let me explain again. Let's compile it first. So we are still printing this. Let me do this also. So here you can see that each value we have two. So first will represent the edge here, and second will be weight. So from 0 we have 1 edge with weight n, and from 1 we have 0 edge and weight with n same. So let's try again. Cool, 09. Let's submit it. Okay, it's correct answer. Let's put some. Okay, thanks for watching. Have a good day.